In this video, I'm going to demonstrate both the product and quotient rules. Here are both of these rules right here. So for a product rule, the derivative of a product of functions is not the product of derivatives. If we could write the function as product of a first factor times a second factor, then the derivative is equal to the second factor times the derivative of a first plus first factor times the derivative of a second. So again, second times the derivative of a first plus first times the derivative of a second. Notice you have two terms. In each term, only one function or the other is differentiated. The other must be left alone, so be careful about that. The quotient rule, after way I've written the product rule, and the reason I write it this way is so that the quotient rule is very similar, so it makes it easier to remember both of them. So derivative of a quotient, so f of t is the numerator, g of t is the denominator, is denominator times the derivative of a numerator minus numerator times the derivative of the denominator divided by the denominator squared. One way that can help remember this is if you think of the numerator as high and the denominator as low, then it's low d high minus high d low over low squared, where d refers to derivative. So I'm going to use the product rule on this function right here, because this is a product of two functions. Then here we have a quotient of two functions, and since both are polynomials, the numerator and denominator, this is a rational function, so we need the quotient rule to compute its derivative. So for the first function, I'm going to first rewrite the function, because it's not suited for differentiation in its present form. Because we have 9 over t cubed, that is best written as 9 times t to the minus 3 for using a power rule later. And then we have the second factor as is. So this first factor is f of t, and the second factor is g of t. So to apply the product rule, we have the second factor undifferentiated, so leave it alone, just write it as is, times the derivative of a first factor. Well, the 7, that's a constant, so you get nothing from that. And now we use a power rule for this part, so we have sorry, just muted that there. So minus 3 times 9, so 9 times minus 3 times t to the minus 4. So that completes the first part of the product rule. For the second part of the product rule, I have the first factor undifferentiated, 7 plus 9t to the minus 3, times the derivative of the second factor. So that's going to be 3 times the derivative of t squared, which is 2t, plus 2t's derivative. Derivative of t is 1, so the derivative of 2t is just going to be 2. And then the minus 3, that's a constant, so we don't get anything from that. So so now, if I were to simplify this, I have 3t squared plus 2t minus 3 times minus 27t to the minus 4 plus 7 plus 9t to the minus 3 times 6t plus 2. So now the derivative is complete, but if I need to simplify it, then I just need to, unfortunately, multiply all of this out. It's going to be a bit of a pain. So we have minus, so 3t squared times minus 27t to the fourth, that's minus 81 t to the, so I have t squared and t to the minus 4, but that's going to give me, you add the exponents, so that would be t to the minus 2. And then I have plus 2t times minus 27t to the 4, so it's minus 54t to the minus 3. Again, adding the exponents. We have a 1 here and a minus 4 here. And then I have minus 3 minus 27, that's plus 81 t to the minus 4. And then I move over here, and I have to, you need FOIL for this. So I have 7 times 6t is 42t. 9t to the minus 3 times 6t is 54t to the minus 2, because we have a minus 3 and a plus 1 as the exponents in that case. And then I have plus 14, the 2 times 7, and then I have plus 18t to the minus 3. So now I can combine some like terms here. So I have minus 81t to the minus 2 and plus 54t to the minus 2. So that's minus 27t to the minus 2. And then I have minus 54t to the minus 3 and plus 18t to the minus 3. Those combine, leaving me with minus 36t to the minus 3. And then I have plus 81t to the minus 4 plus 42t plus 14. And that is my final answer. Derivative simplified as much as possible. Okay, now for the other example, here we need the quotient rule. So I'm going to label my numerator as g of x, my denominator as h of x. So f prime of x is going to be, so remember what I said earlier, remember quotient rule, low d high, so h g prime minus high d low, g h prime, over low squared, h of x squared. So now if I fill in what all these things are, I have my denominator undifferentiated, minus 3x cubed plus 8, times the derivative of a numerator. That's going to be 4 times 9, 36x cubed. And then the plus 1 will not contribute anything, so we can forget about that. And then minus the numerator, 9x to the 4th plus 1, times the derivative of a denominator. Well, that's going to be 3 times minus 3 is minus 9x squared. And then the plus 8 doesn't contribute anything. All over the denominator squared, minus 3x plus cubed plus 8 squared. So now, all that's left is to simplify this. So I have minus 3 times 36, so that's minus 108x to the 6, because we have x cubed and x cubed, you add the exponents. And then I have 8 times 36, so that's 288x cubed. And then over here I have 9 times minus 9, so that's minus 81x to the 6. But there's another minus here that makes it a plus. So I have 81x to the 6, and then 1 times minus 9, the minus 9x squared, but there's another minus, making it a plus. So plus 9x squared. Now, that completes my numerator, but here we have two like terms. So minus 108 and 81, so that combines to give it me minus 27 x to the 6. All over the denominator squared. I'm not going to bother doing anything with that. No need to expand it or anything. And there you have it. That is the derivative computed using the quotient rule.